All right, good morning, and this is not up to date. What happened here? All right, let me just do a quick pull here. All right, so you should be able to do a git pull upstream main, and that should work. And here I've got lecture 3-2 covering dictionaries. And let's take a look. All right, so so far we're just kind of covering some basic data structures in Python, and so far we've seen the list. We've talked a little bit about strings, and now we want to talk about dictionaries. Dictionaries are a really important data structure to Python, and a lot of Python's kind of really beautiful features, I guess, are powered by dictionaries. And so so if you can master dictionaries, you can do a lot of kind of what we might say Pythonic coding. Okay, so here, let me clear all the outputs here. So what a dictionary is it is a structure that is mutable, kind of like a list, meaning you create some object in memory and you can modify that object directly at its kind of memory address, okay? And what dictionaries do is it maps what we call keys to values. So you're going to have kind of two sets of values. You've got keys and you have values. And, you know, lists, you access lists by position. So you say something like, give me the fifth item in the list, okay? Or index position 15, give me index position 2, something like that. With a dictionary, you access the values based on their key, all right? So you always have kind of this mapping that says, you know, A corresponds to this value and key B corresponds to this value or something like that. All right. If you wanted to just create a dictionary manually, you could just use curly braces to do so. And so you would use curly braces and you use a colon, and they're in the form key to value. Okay. If your keys are strings, you'll want to put them in quotes. So you'll do something like people, and then here I guess it will be names of some people and maybe their ages and years or something. So we have Adam : 25, Bob : 19, Carl : 30. Okay, that creates a dictionary, and then you can ask, what is this dictionary? And there you go. There's your dictionary. That's there. Okay. If your keys are simple strings, you aren't required to actually put quotes around them. And so if I did people2 and I defined it this way, almost the same way, but just without the quotes, it will automatically enclose these things in quotes. But in general, I recommend using the quotes explicitly rather than counting on Python's kind of automatic conversion into strings. Okay. So that's if you wanted to just kind of type out a dictionary by hand, which, you know, in a pinch you can do, but that's probably not the common way of creating a dictionary. So another thing you can do is you can zip together two lists, okay? So there is a function in Python called zip, all right? And basically the input for zip is one iterable and another iterable. So here I'm going to take two lists. So a list is an iterable and another list, it would be the other iterable. But you got a bunch of these iterable things, like basically anything that you can kind of like do a for I in something is an iterable, something that you can iterate over. So, you know, strings and tuples and even dictionaries are iterables. But here we'll take two lists and kind of zip them together. And what a zip does is it's going to kind of interweave these things. It's going to kind of do like First item from here gets kind of zipped together with the first item over here. Second item over here gets zipped together with the second item over here. Third item over here gets zipped together with the third item over there. Again, Python is lazy. So if you say zip together this list, Adam, Bob, Carl, and zip the list of integers 25, 19, and 30, Python says, okay, I'll do it, but it doesn't actually like produce anything. And so if you want to kind of see it actually get zipped together, you can take that zip object and put it inside dictionary, the function dictionary, and then Python will say, okay, I will actually go through and match this, right? Because you can imagine your list being like 1,000,000 entries long and another list being 1,000,000 entries long. And so when you zip these things together, you might only want to get like the 300th object, okay, in that zip thing. And so by default, so you can also iterate over a zip thing and get just the 300th thing there. But you know, Python doesn't necessarily want to evaluate and match up all you know, million things, right? It's kind of like if somebody gave you a big stack of papers and said like collate, you know, the first page with this page and like staple them together. And it would be a little bit frustrating to you if somebody gave you like 10,000 sheets and you did 10,000 and they just said, oh, you know what, I only needed the first 100, right? You'd get a little annoyed that why did I do the other, whatever, 9,900, I can't even do the math here. But why did I do all of these other things, right? And Python is kind of like that. It's going to just say like, okay, I know that's what you want. Oh, you want 100? Like just the first 100? Okay, I'm going to just rapidly give you the first 100, right? And it's not going to do the whole thing. Here, I'm saying dictionary on the entire thing, and so then it'll go ahead and evaluate all of them. But it's, but again, it's inherently lazy, and that's a design feature. That's a feature of Python. It's not like we use lazy as like, oh, people are lazy, but like that's a bad thing. But you can also think of it as just, now I'm just efficient with my energy, right? So, and that's basically what Python is. It's trying to be efficient with your computational resources. It doesn't want to waste any of it until you go. So here we zipped together Adam, Bob, Carl, 25, 19, 30, and then we say make a dictionary out of it. And so you can see the first list got turned into keys and the second list got turned into the values there. Okay, here is a list of tuples here, and it could have been a list of lists, but basically I've got each of these tuples or lists or iterables here are just is a length of 2, right? So I've got a list, and the first item is a tuple that says Adam, comma 25, and then the second item is a tuple that says Bob, comma 19, and the third is a tuple that says Carl, comma 30. And so I can also say, hey, make a dictionary of this thing, and that's going to be a bunch of key value pairs, and we get you know, another dictionary there. So these are just some ways of creating dictionaries. You can also create dictionaries based on data frames and stuff like that, kind of extracting out columns and stuff. But this is you know, zipping kind of lists together and then making a dictionary that I'd say is probably a very common way, especially if you have these big lists. Okay, so once you have the dictionary, so all of these things, people 4, people 3, people 2, people 1, they're all the same. Adam 25, Bob 19, Carl 30. You use just square brackets and the name of the key to access the value. So we're going to say people Bob, and it gives us 19, okay? You can also, there is the get method, okay? And so you can do people.get Bob, and this will also yield 19. And so, well, what's the difference? Why do I have square brackets to access these things, and why do I have the get method? What's the difference there, right? Well, the difference is what happens if you ask for a key that doesn't exist, okay? The square brackets will give you an error if you ask for something that doesn't exist. So if you say people, square bracket, Joe, okay? Joe is not a key that exists in my dictionary, so you're gonna get a key error, okay? Key error just means, hey, this key doesn't exist, or I'm having a problem with the key when I'm using it on this dictionary here, okay? Whereas if you do people.get okay, and you give it a key that doesn't exist, it's going to return none. Now remember, if Python returns a none, it normally doesn't print anything out. Okay, it normally just so here if I get rid of the print here, nothing shows up. Okay, but if you call print and the object is none, okay, then it will print out none. Okay, but so people.get with a key that doesn't exist, it'll return none. You can also with get you can also return a default value. So if you wanted to return, say, 0, if it doesn't find something, you can do that as well. Okay, so people.get you have an optional argument to give you a default value for something that doesn't exist. Okay, the square bracket with the key, that's probably the most common way to access values in the dictionary. But again, you're going to get errors if something doesn't exist. And so if you want like safety against that, you would use .get. But maybe you do want an error, and so sometimes we treat errors as things that we need to avoid. Okay, and in general, we don't want errors, but sometimes errors are actually good because you have to think, once you create an application, once you create a function that goes out there, people they don't always follow the rules. And so sometimes they'll put in inputs that shouldn't be or just don't make sense. And so you need a way to kind of catch all of these things. And inevitably, you cannot think of every single thing that a human on the other side is going to do. And so you also need kind of just like, if something goes wrong, we need to figure something out. And so errors are also useful in that kind of way, and to kind of catch these things. Okay, keys can be anything that is immutable. Okay, so you can use strings are immutable, numbers are immutable, tuples, even functions themselves are mutables. Okay. Dictionaries aren't allowed to have duplicate keys, okay? And you cannot use mutable objects. You cannot use a list as a dictionary key. You cannot use, I guess, other dictionaries which are mutable as dictionary keys or things like that, okay? As far as values, though, values can be anything. There's no restriction on what the value is. So the value can be a list, the value can be a string, the value can be other dictionaries, okay? So here I have a dictionary, and what Python does is it reads left to right, and so here I said dictionaries are not allowed to have duplicate keys, okay? But here, okay, so let me just kind of create this. And so here I got 1 is going to go to length, the integer 3 goes to that, 4, 2, and so on and so forth. So I can say, hey, what was D1? This is going to be the function length, okay? What is D2? That's going to be the list 24 and 5. D3 is going to be the dictionary that maps first to A, and D4 is going to release the tuple here, okay? If you try to give it a duplicate key, all right? So here I'm going to go D1 is length, 3 is this, 4 is this, 2 is this, 4 is house, okay? Python reads this left to right, and basically when it encounters this key 4 the second time, it's going to just update the value, and it's going to just, whatever this was will just get thrown out, and it gets replaced with this. So if I do that, this all remains the same, but 4 here is going to be house. And there's nothing in the dictionary that has 1, 2 there. So Python just reads left to right as it's reading through this dictionary. And so if it encounters a duplicate key, it just kind of updates the value associated with that key. Okay, so lists are allowed to be values in a dictionary. They cannot be keys in the dictionary because, again, the rule is only immutable objects can be dictionary keys. And so immutable objects have this property known as being hashable, which you don't have to worry about. But basically, if it's immutable, you can hash it, and dictionaries use something called a hash table. But if it's mutable, like a list, it is not hashable, and so you cannot use it. So here I'm going to have L is a list with the values 1, 2. T is a tuple with the values 1, 2. We're going to create a dictionary D, and you can create new kind of values in the dictionary just kind of by assignment. So I can just say, hey, D, I want to do A, and we're going to set this to, I don't know, some value. Okay. And that's fine. And I can say, hey, what is our dictionary right now? And right now it contains the key A and some value. If you try to do this, but use a list as your key here, that's not going to work, okay? We get unhashable type list, okay? If I do DT, then T being the tuple, this is okay. So, so if I ask what is the dictionary here, now I have A here and T here, okay? And the reason why is this, okay? Because look, I used T here, and basically we don't want this key changing, right? So if I had a list, I could do something like L.append X, right? And then so now L would be this, and if this were the key in the dictionary, now the key in the dictionary would go from one, a list that has 1, 2, to now a list that has 1, 2, and X, okay? But because the tuple is immutable, I don't have to worry about some situation like this happening, okay? This is an immutable thing, 1, 2. I don't ever have to worry about this ever changing, okay? The tuple, I can't just say, hey, change. I'm not allowed to come in here and say, okay, here's my tuple. I want to change the second value in tuple to be 0. All right, this is not allowed with a tuple. Okay, so I can't I can't do that. Right. So let me see. So this is the memory address of the tuple T, and if I ask D.keys, let me get the first thing. Well, I don't know, but okay. So so I don't ever have to worry about the key in the dictionary ever changing. So that's why only immutable objects are. Okay. Okay. So I showed this. Python, you cannot have duplicate keys in a dictionary, but again, it reads left to right, and so anything that shows up again, it just kind of updates the value. So if I do D is A1, B10, A2, B0, A3, you're going to get a dictionary with values A is 3 and B is 0, because those are kind of the latest values that you have. So if you say, hey, what is dictionary B? It's going to be the latest kind of value of key, value that it got associated with the key B as it read left to right. And for A, it's going to be 3, right? So again, only, so if you do this, it just updates the value. It's not going to produce a duplicate key in the dictionary, okay? Now, one thing is that dictionaries are not indexed by position, okay? So here I have this dictionary, Adam, Bob, Carl, but you cannot, you can't just reference things by position. So you can't say, hey, what's in the first or 0 index position? This is going to look for key 0, and it's going to say key error. There's no 0 in this dictionary. All right. Okay. Before I forget, let me give you first view quiz answer is the letter D. D as in dictionary. Okay. Is our first view quiz answer. D. Similarly, you cannot index subset dictionaries based on position, so you also cannot slice dictionaries either, okay? So you can't say, hey, give me from index 0 to index 2. That says, hey, it's not, a dictionary cannot be sliced. Okay, you can't do stuff like, hey, give me from Adam through Carl either. Okay, and it's going to say, hey, you can't do that. Okay, it just keeps saying it's unhashable type slice. So you can't slice a dictionary. Dictionaries. So there's a in operator that can be used on lists, can be used on dictionaries and things like that. Okay, and so you can kind of say, hey, is Adam a key that exists inside the dictionary? And it's going to come back true. Okay. If you want to check for values, like the value 19, I think Bob is 19. The in here is not going to work, okay, because it's going to yield false because it checks only the keys. And but you can do people.values. Okay, people.values. So you can dictionaries always all dictionaries have kind of these view objects. So you have .values, people.values, and you have people.keys. Okay, and you can just kind of ask, hey, is this thing inside the dictionary? One neat thing about dictionaries is that using the in operator on dictionaries is almost instantaneous. Okay. With a list, Python starts at the beginning of the list and reads through it. Okay, so it's kind of, again, it's like having this like a stack of papers. Okay, so I don't know, let's say I have like a stack of exams from this class, and then I give the stack to you and I say, hey, is student Joe Bruin in the class? Okay, and what that would require you to do is start at the top of the stack, and you look at the first paper and say, is that Joe Bruin? And you look at the next paper, is that Joe Bruin? Next paper, is that Joe Bruin? And you have to kind of go through this stack one at a time until you kind of encounter Joe Bruin, or you reach the bottom and you didn't find it, and you say, I couldn't find it, right? And you'll either yield true, I found it, or false, I didn't find it. Okay. The dictionary, you have kind of the keys and the values, and yet the keys exist in something called a hash table. And so it's almost like I have not just the stack of papers, but I also have, I don't know, like a table of contents at the top. And so you can kind of just scan the table of contents without having to flip through every single page. Okay? And so just checking to see if an object exists inside the dictionary as a key is a really, really, really fast thing. And so if you're going to have a big list, and so this is one of your upcoming homeworks. I forget, it's either homework 2 or homework 3. I have you create a dictionary, and it's well, I think first I give you kind of this big list of words. Okay, you're going to download this words file, and it's got like almost all of the, that's this homework, right? So you get this big list of words, and I think this one, you just have to kind of write a search algorithm to find things, and you take the list and you divide it in half or something, I don't remember. And it, you want to, if you just said in, and it's got, you know, hundreds of thousands of words or whatever, 10,000 words in it, it takes a long time to kind of search all of these things, okay? But with a dictionary, you'll create kind of a dictionary version of the list of words, and you'll find that searching for these things are now instantaneous. So, so sometimes you just have this big list of words, and you want the speed of a dictionary. So I guess the disadvantage is that the dictionary takes up more space in memory. I think, yeah, it does than the list, but you get all of these kind of speed benefits as well. So, so sometimes you just create a dictionary where all the keys are these words, and the associated value is just 0 for all of them. Okay, because you don't actually care what the value is. You just care what the keys are, and you can just create, handle that. Anyway, so the in operator uses different algorithms for lists and dictionaries. For lists, it searches the elements of lists in order, and as the list gets longer, then the search time gets longer in proportion to the length of the thing, okay? Whereas dictionaries use a data structure called a hash table, and the in operator takes about the same amount of time whether or not there are, a million items in the dictionary or not, okay? All right, so here is our dictionary of people, Adam, Bob, and Carl. And again, I think I showed you this. You can create new entries by just kind of giving it a key that doesn't exist in there and providing a value associated with it. And you can also update values by using a key that does exist and providing a new value for it, okay? And so here, people gets updated. Now it has Derek, and the value associated with key Adam, it gets updated, okay? If you want to remove a key, you use the operator delete. So here's people. I'm going to call delete on people Carl, and here we get this, okay? So some of these operators just feel a little bit funny because it's a little bit different from a function, right? So functions you always kind of call them with parentheses, and here you just kind of call this operator here. Okay, we have methods, okay, like pop, okay. Now with a list, pop, the default was it would pop the last value in the list. You can also say pop 0 or pop 5 or whatever, and it'd pop the value at that index position. Here, dictionaries, again, they don't operate based on position. So you can't say, hey, what is the last item in the dictionary? I mean, the last item in the dictionary is Derek, but dictionaries don't operate that way. So when you give it pop, you have to give it a key. And you say, hey, what is the thing that you want to be popped pop from it, okay? So you can say pop Adam, and it will pop out that value, the value associated with Adam, which is 26, okay? And now that thing has been removed from the dictionary. And so people now only has Bob and Derek left in it. Trying to, if you wanted to like join dictionaries together or something like that, or if you wanted to just update, you can use this update method, okay? And this can be used to add more keys from another dictionary. So rather than just doing one at a time, right? Here I wanted to add Derek, and I did people Derek equal 33. If you have a whole bunch of these things, so here I'm going to start off with people A, Adam, Bob, and Carl, and I've got people B, Dave, Earl, and Fred. Okay, I can do update people A dot update with people B, and you can do that. Okay, and this will kind of join them together, and we added Dave, Earl, and Fred. Okay, you can't just with dictionaries, you can't just, there's no plus operator. So with lists, you can kind of join one list and another list with a plus operator, right? You can have list A plus list B, and you can take that and do something like that. With let me just start back up here. I'm going to redefine people A. Okay, so people A is here. I can't do people A plus people B. Okay, it says unsupported operator plus. Why do you think the plus operator is unsupported? Because effectively, I just want A, B, C, D, E, F all together, right? This is just what I want. I want people A, update people B. Why do you think I can't just do people A plus people B to get the same thing? Because that's effectively what I want, right? What do you think? What if I had this? Okay, what if people A was Adam, Bob, and Carl, and people B was Adam, Earl, and Fred? Okay, if I tried to do people A plus people B, what would happen? we would have two Adams, and then Python is forced to kind of make an ambiguous choice about which, do I keep the 25, do I keep the 35, okay? By using people A, update people B, I know that the values that I need to update with are the ones in people B. And so we get Adam 35, Bob, Carl, Earl, and Fred here, okay? That would be different from if I redefine people A and people B, and if I did people B update with people A, people B will get updated with the values in people A, and now we'll get 20. We will keep the 25, the values from 25. So by saying you're going to take the existing dictionary and update it with values or keys and values in the other dictionary, we get rid of the ambiguity problem that can arise when you have just a simple plus operator. What was the D name? I forget. Huh? Dave. That's right. Thanks. Not that it matters, but so you use update. So if you have that, and that takes care of the problem that if you have a duplicate key or something, it's just going to overwrite the old value rather than something like that. Okay. So here's people A. Here's people C with Fred and Gary, and we can do people A update with people C, and then so now Fred goes from 27 to 99. And something like that, okay? And then now that it doesn't fit all the way sideways, it starts going vertically here. Okay, dictionaries support these dynamic view objects, okay? The view objects change as the dictionaries change themselves. So here I've got people is Adam, Bob, and Carl again. And I'm going to create view objects. Names will be the people keys. Ages will be the people values. So names is this view object that has Adam, Bob, says dictionary keys, Adam, Bob, Carl. Ages will be the dictionary values, 25, 19, 30. Okay. Here I'm going to update the dictionary, throw in ed. Okay, I'm going to throw in ed, age 40. Without needing to redefine what names or ages are, the corresponding view objects update. So now the view objects for names now includes ed, ages now includes 40. These are view objects, and they get updated instantaneously. This requires you to modify the object in memory, though. Okay, so here, I had the people as this dictionary. Okay, I've got a whatever 25, and B. I have names, but I'm just calling them A, B, and C. Okay, I don't know, whatever, right? And then I modified this. Okay, the actual thing by doing people E is equal to whatever, something like this, and that's the view object names points to that. Ages also points to the same object here. If I let me just show you something. Okay, so I'm gonna just call people2 is equal to people. Okay. So people2 is still pointing back to the same object. Let me just create a new dictionary, and I'm going to call this thing people. All right. So here I'm going to do x is 10 and y is 100. Okay. This creates an entire new dictionary. This is an entire new dictionary with x and y. These things still point back to people here, okay? So people2 is this people is now this. Okay, what is, why can't I? Okay, so if I ask for names, it still points to Adam, Bob, and Carl because names is still pointing back to this object. And so here calling this thing people just creates a new object. It's not, this name people no longer points to this, okay, but names is still pointing to this object. Ages is still pointing to this object, right? And I can, like I gave myself a way to kind of still talk to this by having people too point to this thing. So I can still kind of do like people two, you know, F is gonna equal, I don't know, 45 or something like that. And so if I ask, you know, what are names here, now we have F in there as well, okay? But if I didn't have that name, I wouldn't have a way to kind of like interact with this item in memory anymore, okay? And now people over here is just, this is just an entirely separate thing. So when you do something like this, Python doesn't work off of the name, okay? It takes, here it's creating a new object in memory, and it's just taking that name people and it's now associating this, okay? So that's, you know, that's what we're doing, okay? Does that kind of make sense as far as like interacting with these things in memory and what's referring to it? Okay, second view quiz answer is C. C as in cat. C as in cat. Okay. View objects only support a few functions like length, the length of the view object, and the in operator. Okay, like is a value inside there. So you can say, hey, what's the length of ages? Now the length of ages is 5. Okay. We can ask what are ages, and we got this. Is you can do 35 in ages. That's false. You can take the ages and turn it into a list. Okay. If you do this though, okay, this is a list of the dictionary values at that moment in time. This is no longer a view object. This is no longer going to get automatically updated. This is just basically a list copy of this. And so here I can add like a new value to the dictionary. And we're going to have Frank 29. So ages is dynamic. Why did that? Oh. Okay. This didn't work. Why didn't this work? Because earlier I changed what people is, and so now people is going to be X, Y, and Frank. Okay, so let me go back. How do I get people to be back to this? Okay, so I need to have people to be people too. Okay, and then so now, okay, so people will now reference back to the dictionary. Okay, so now this will work. Okay, people is going to be Frank 2. And so now this is dynamic. Now that I've updated this, 29 shows up into the dictionary. Whereas the list that I created earlier is not dynamic because again, this was just a list copy of the dictionary values at that moment in time. Okay. I can though, because it's a list, I can reference things by index. Whereas, you know, still ages is the dictionary values. You can't kind of just say, hey, what is the index 3 position? Okay. You also can't, it's not a dictionary. Okay. The dictionary doesn't have like the key value pair dynamic in terms of like referencing values here. You have to use the dictionary itself. Okay. You can ask for the items in the dictionary, and this will give you basically kind of like a tuples of all of the keys and value pairs. Okay, and again, you can kind of turn this into a list of tuples. But again, here people.items is dynamic. People.items is dynamic. All right, so here's a simple application. We can use the dictionary as a collection or a counter. There is something in Python, kind of this built-in data structure called the counter anyway. But here I just kind of wanted to show us something. And so what we're going to do is, let's say you want to take a string and you want to count how many times each letter appears. You could create 26 different variables, one letter for each alphabet. You could then kind of iterate or traverse the string, and for every kind of character that it encounters, you increment the corresponding counter. Or you could create a list of 26 elements and convert each character to a number, and then using that. Or here we can just create a dictionary, and we'll use the characters as keys, and the values will be how many times each of those things appears. So that's what I'm going to do here. I'm going to create a function called histogram, and what it will do is it will input a string, and it will iterate over the string. For every character in that string, it's going to check, is that character a key that exists in the dictionary? So the very first time it encounters a letter, it's going to say, well, it's not a key in the dictionary. And then in that case, it will create that key in the dictionary using the character, and it will start out the count as 1. And then otherwise, okay, that means the character is in the dictionary, then just take the current count and increment it by 1, okay? And at the end, return the dictionary D. So here we're going to say make a histogram out of the word abracadabra, okay? So it's going to go through A, and it will do 1, then it will go B, add 1 to B, then it will go R, add 1 to R, or just set 1 to R. And then it will encounter A for the second time, and it will say A is already in the dictionary, so we'll take the 1 and add 1 to it. Now it'll be a 2. And it's going to do that, and at the end it's going to find 5 A's, right? And so we have 5 A's, 2 B's, 2 R's, 1 C, and 1 D. Okay. You can then kind of iterate over the dictionary itself, and this is really simple. We'll just kind of print out each key and the corresponding value, and so we'll say, hey, we got 5 A's and 2 B's or whatever. And you could make this more complicated, and you can say do something like print key, and you can write appears this times or something like that, right? And so you can say A appears 5 times or something like that. However you want to do it. You can make this line of code as complicated as you want to do. You can take the dictionary, and here it creates the dictionary in the order that it encounters these letters, right? So as it's going abracadabra, it goes A, B, R, C, and D. And if you wanted to, you can take H and you can sort it. You can take the resulting dictionary and sort it based on the key. And so now it will do, A, B, C, D, R, and so on and so forth. So you can call sorted on a dictionary, and we'll use the keys and sort them in order. Okay. Dictionaries are designed to return values when you provide a key. However, if you want to kind of find the key associated with a particular value, that's harder, okay? And it requires you to perform a search. Now, one of the problems, the reason why this is not a built-in feature is because Python doesn't care what the values are in a dictionary, and so you can have duplicate values, right? You can't have duplicate keys, but over here, B shows up twice and R shows up twice. Okay, so if I said, hey, what are the keys that are associated with 2, that's a little bit trickier. So here I'm going to say for each key in the dictionary, if that thing is equal to the value, return the key. And so this is only going to kind of give me the first instance of this, okay? Because I'm going to just say, hey, is 2 in the dictionary? It's going to look up the value here. It's going to look up the value here, and here it will do this, okay? And if I say look up the value 4, here I can use the expression raise, okay, or the operator raise here. And what this is used to kind of give errors to the user. And so here there's different kinds of errors that you can do. you can do, just look up Python exceptions, and there's a whole bunch of different kinds of errors that you can do. All right, index error, key error, memory error, name error. All right, and so here I can do, this gives me lookup error, value doesn't appear in dictionary. Now there's no like, you're supposed to use the certain kinds of errors for each of these things, but there's nothing that stops you from using the wrong type of error. This is not a name error. It's a lookup error because it couldn't find something in the thing. But there's no like, which of these things are you supposed to use is really up to you as far as, making it easier for you to understand what went wrong. Okay, so there's nothing. A lookup error is supposed to be when you couldn't look up the thing, and that's what it happens, and that's what kind of makes sense here. But again, these are just built-in exceptions. You can just kind of call any of these things, and so if you, it's like, it's like being a referee at a game, and you see a foul, and then you intentionally call the wrong rule, right? You say, it should be, the violation was holding, but you instead intentionally call, I don't know, roughing the passer or something like that. And like, people would get confused and be like, what are you, you're the worst referee ever. And yeah, doing something like that, somebody would say, you're using this wrong, you are a bad coder, but Okay, so anyway, you have this, you can just look up the Python different kind of exceptions out there, and that's what you have. Okay, so here, I'm creating what's called an inverted dictionary, all right? And so here we're gonna just kind of take the dictionary and try to invert it, and this will kind of help me. So I've got kind of like my histogram here, and notice what I do is one kind of limitation here was that if I said look up the value 2, it only gave me the value B, but really there were two letters in here, B and R, that showed up twice. And so here the inverted dictionary is going to kind of first reverse the thing, and if it encounters the same value more than once, then it will append it. So so here I have parrot, and P appears once, A appears once, R appears twice, O appeared. And so here if I invert this, now I get kind of two keys. One, and it says these values appeared once, and here, let me just call H2 on, say, abracadabra, and we will invert the dictionary on H2, okay? And then so now we have the key 2, and B and R will show up, and so on and so forth. So that's kind of if you wanted to create such a thing as an inverted dictionary. Okay, we'll wrap it up here. And I'll give those of you here the last